Manually deploying code means stopping your development work to log into servers, pull repositories, and restart services. Every manual update interrupts your workflow. An automated pipeline handles all of those steps in the background the moment you save your code. The goal today is to build that pipeline. We are going to connect a GitHub repository directly to an AWS EC2 instance using GitHub Actions. Before we start building, you need 3 elements ready to go: an active AWS account, a NestJS app in GitHub, and a registered domain name. Setting this pipeline up takes a little bit of careful configuration, but doing it once means your code updates automatically every time you push. You eliminate human error from the release process, leaving you free to focus strictly on building product features. Start in your AWS dashboard and launch a new EC2 instance. For most starting projects, selecting the Ubuntu operating system on a T2.micro instance provides plenty of power and usually falls under the free tier. During setup, you'll be prompted to create a key pair. Download this .pem file and store it somewhere safe. If you lose this key, you permanently lose SSH access to your server. This server firewall settings panel shows the exact ports we need active to communicate with the outside world. Open port 80 for HTTP traffic, port 443 for HTTPS traffic, and port 22 so we can access the terminal via SSH. Once the instance is running, assign it a public elastic IP address. Then head to your domain registrar and create an A record pointing your custom domain directly to that new IP. If these network and access rules aren't set precisely, GitHub Actions will hit a wall. Proper configuration here is what allows the deployment pipeline to connect to the server at all. Open your local terminal. Using that key you saved earlier, authenticate and connect to your remote EC2 server via SSH. Once inside, run the standard apt update commands to refresh the Ubuntu package lists. Then, follow the official documentation commands to install Docker and Docker Compose. Type docker -- version in the prompt to confirm the engine is running and ready to accept commands. Wrapping your NestJS application in a Docker container ensures the exact same dependencies and environment variables exist in the cloud as they do on your local machine. This diagram illustrates a reverse proxy. Instead of external web traffic hitting your NestJS app directly, the traffic hits an Nginx shield first. It acts as a mandatory security checkpoint. Avoid exposing your application ports to localhost. Instead, keep your NestJS service completely hidden, forcing Nginx to route approved requests directly into an internal Docker network. Next, install certbot. It generates Let's Encrypt SSL certificates and attaches them to the proxy, encrypting the connection and automatically handling upcoming renewals in the background. Serving API data over plain HTTP leaves credentials exposed in transit. Automating HTTPS encryption secures the payload and maintains user trust. Our server is ready, but GitHub needs a secure way to push the code, and the server needs permission to pull it. We have to establish a 2-way authentication handshake. First, generate a new SSH key pair directly on your EC2 instance. Take the public half of that key and paste it into your GitHub repository's deploy keys settings. Now, go the other direction. Take the server's public IP, the username, and your original private access key, and save them as encrypted action secrets inside your GitHub repository. By passing these values as encrypted secrets, your infrastructure credentials remain completely hidden from the public version control history, securing your server against unauthorized access. This is a GitHub Actions workflow. You must save this YAML file inside a .github/workflows folder at the root of your project. The file is split into phases. The first phase builds the Docker containers locally to ensure there are no compilation errors. If that succeeds, the pipeline moves to the server execution phase. During execution, the script invokes those encrypted secrets we just saved, quietly using them to SSH into the server and pull the latest code. Once written, this single configuration file handles the heavy lifting, replacing hours of repetitive manual deployment commands with an automated sequence. To trigger the sequence, commit your workflow file and push it up to the main branch. Open the Actions tab in your repository. You can watch the console output in real time as the platform provisions an environment, builds your containers, and executes the remote server commands. When the status turns green, open a browser and navigate to your custom domain. Check the URL bar for the secure lock icon and test an API endpoint to confirm your NestJS logic is live. It takes careful setup to establish the server, security, and access rules. But once the pipeline is active, you can scale your projects without deployment friction acting as a bottleneck, pushing updates as fast as you can write them.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.